This is an abandoned office building. It was built in 1972 and closed in 1991. In this video, we go straight up to the lift machinery, and with my usual attention to detail, I'll explain how a lot of the electromechanical machinery works. What makes them fascinating is the work that went into designing and installing such systems long before the introduction of computers. We're on our way from the old reception to the roof. To see more content relating to the building and photos of how the offices once looked, please see the video description or click the link above to see the first video. We'll have a look at the lift car later, which has been on the top floor for a long time. This is one of the two lift machine rooms. In here are 3 lifts. It contains the 2 passenger lifts from the reception and a 3rd lift that serves all floors, including the underground car park. The 2 passenger lifts share a very clever but simple call system that I'll explain later. This unit is mechanically linked with the lift car. On the front are all the call relays. The C relays are from the floor buttons inside the lift car. The D relays are from the down buttons on each landing, and you'll notice there's no up relays. The central pole has plates that rotate when the lift moves. Each plate represents a floor and where the lift should stop from travelling in either direction. These are floor bars, representing each floor the lift serves. If we draw a line across them, they match exactly the spacing between each floor. The first landing is always labelled 1, regardless of the floor numbering system in the building. The highest floor is relabelled T for top. Let's come back to this in a moment when we look at lift 1. These are the motors for lift 1 and 2. The motor runs from a DC voltage, which is supplied from a small generator located on the floor beside each cabinet. As before, these are the car call relays for the first lift. The up landing buttons connect only to this lift, and this is how the call system works. Firstly, these are the landing calls, and these circles represent the floor buttons inside the lift car. This is how each relay from lift 1 and lift 2 connect. The C relays from the buttons inside each lift send the lift to the requested floor. The call buttons on the landings, however, are shared between lift 1 and 2. When both lifts are idle, lift 1 responds to the up landing calls, whilst lift 2 responds to the down calls. This is the basic principle of operation, but there are other factors that can change this, including a relay labelled TG. The control cabinet is dominated by relays. Each relay in this cabinet has an abbreviation. In a separate video, I take you through the cabinet relays and a longer description of what each one does. I'll add a link to it on the end screen later on. You'll notice this lift has many more floor bars than the others. Again, if we draw out the floor bar positions and compare it with the building, we can see the floor spacing. This lift serves every floor in the building, including the basement car park. The floor numbering from the basement upwards makes the ground floor level 4, and 8 is the top level. And talking of the car park, Daniel Meakin has provided some extra footage, starting from a door where the general public access the car park. With lighting and wall coverings having been upgraded, this just looks like any other ordinary car park. Apart from the old Otis lift, of course. And I'm not sure that I'd want to ride this, even if it were still working. Behind the floor bars is a moving carriage. This has many contacts for different purposes. I'm going to explain this device in a lot more detail. There's lots to cover, so I'm trying to keep this to the point so that we can move on. Here are the floor bars, one per floor. Each floor has many contacts on them. I'll go through what they do in a moment. The direction switches wire into a series circuit, but there's a lot more to explain about them later on. These and all the other contacts connect to either the call relays or the controller. That's a lot of wires. And then the carriage. This moves up and down and represents the lift position in the shaft. And not forgetting that this mechanism is located in the lift motor room. It's mechanically linked by what looks like a chain. It's called selector tape and runs from the lift car to the counterweight via a wheel in the motor room. When the lift moves, so does the carriage. When a call is placed, one of the floor relays you saw earlier applies a voltage to one of the floor bar contacts. And by the way, the contacts do not actually light up. This is just for illustration purposes, so you can see where the voltages are. Each row of contacts has a function. Switches for the call direction logic, up haul calls, down haul calls, which are the landing buttons, car calls for the buttons inside the lift, a stop contact, and contacts that run the floor position lamps. In reality, there's even more than this, such as contacts that reset the call relays and more. Now to introduce the brushes on the carriage that make an electrical connection to the floor bar contacts as it passes them. The floor display brush is always live. This voltage passes to the floor bars to light up the floor where the lift is. Each floor bar has a floor display contact and it connects to the corresponding lamp. The lift in this video has one in the lift car and one on the ground floor. Each brush on the carriage is also wired back to the controller to make a circuit with the floor bar contact as it passes them. Replaying the same sequence as the lift is going up, collecting a down call doesn't make logical sense, so it's ignored. When these find a voltage from a floor bar call contact, the stopping sequence activates, which now livens up the stop contacts, and the lift also switches to slow speed. When you have the spinning disc, this stop contact isn't required. Instead, the slowing and stopping is controlled by the spinning disc. Together with a DC generator, they bring the lift into a floor smoothly and precisely. The lift always heads towards the furthest call. The carriage now travels towards more calls, until a brush picks up the voltage from a floor bar call, in the right direction of course. The car call brush is always active, whereas the up and down brushes ignore anything going the other way, unless it's the last call. Coming up later, I'll explain the direction logic circuit and a few other interesting things about it. The next stop is the goods lift at the other end of the building. Being a lift on its own, all call buttons are wired back to these relays. As before, the U and D relays connect to the up and down buttons on the landings. The C relays connect to the floor buttons inside the lift car. It's amazing the amount of work that went into connecting this up, especially as the wires are all similar, if not identical. The carriage on this floor selector is way below the bottom floor. With the selector tape that links it to the lift car gone, it's free-wheeled into this position. This is the normally closed floor switch. It's a very simple switch, but it's vital to tell the lift which direction to go to reach a call. To help this animation work better, I'm redrawing all these call direction switches on the left. You'll notice that when a lift is not present, all switches close, forming a line from top to bottom. Now to bring in the carriage, which represents the lift in the shaft. On one side is the ramp that separates the switches on the floor bars. When the carriage travels, it always breaks the next switch before clearing the current switch. This is very important, and I'll explain why in a bit. The voltage from the up and down buttons connect to this line, and it's the same for the car calls. The lift's position breaks the line. If voltage reaches top or bottom, this commands the lift to go up or down, creating the direction logic. With the lift at the second floor, now you can see the direction the voltage takes to either the up or down command. The lift will now travel in its current direction until voltage is lost to its current up or down command. The landing calls below the lift will set the down direction. The carriage is again looking for voltages from the call contacts as it travels past them, as we explained earlier in the video. So now why it's very important that the next floor switch is activated before the current one is released. Let's downsize the ramp so the floor switch activates one at a time. When the lift is moving, let's say there is a power outage. And now the power is back on. With the lift between floors, now try selecting a call from the landings or from within the lift car. The direction logic is lost because voltage is allowed to flow both to the up and down commands. Now let's try that again, this time with a longer ramp that reaches between floor bars. Now it doesn't matter where the lift stops, the direction logic is maintained. To see this whole thing in action from a working Otis lift, please see the link on the end screen of this video. Now a look at the back of the cabinet, and hopefully you'll agree with me. The work that went into designing and wiring these cabinets is quite exceptional. Each wire creates a circuit, linked to other circuits that deliver a function, all electromechanical. Nowadays, gone are the need for lift machine rooms like this. Now to have a look at the lift cars. The whole lift system was installed by Otis in 1972. Even the doors still have their old rubber buffers that used to reopen the doors if they hit something whilst closing. Each lift has a floor position panel and an emergency phone. The second lift is way down, just above the ground floor. The motor room above now has openings which create airflow down the shaft, and this very eerie atmosphere. If you found this video interesting, we are asking if you would consider subscribing to the Mr. Matt and Mr. Che channel. I spend a lot of time editing videos to make them as interesting and as detailed as possible. To see some further content based on this video, please see the video links in the description or click the videos on the end screen. And thank you very much for watching.